Wonderful speech about esports and its influence on STEM. I really feel like esports is definitely going to make a huge influence in making history, which is also the theme of the STEM talks, by the way, I forgot to mention earlier. Yes, so thank you so much for that. That was awesome. Okay, so our next speaker has been our former vice president of Math and Engineering Club and is currently going to Cal Poly Pomona for aerospace engineering. Please welcome Jesus Palazuelos.
Good evening, everyone. So, my name is Jesus Palazuelos. For those of you that don't know me, I am a former student, like Sarah said, and I was pretty involved here at my time here. And I'm now going to Cal Poly Pomona, which is an amazing school. I love that school so much. And today I want to talk to you guys about how I came up with this topic. So the way I came up with this topic was I listed every single thing that I take classes for, such as I'm going to keep dynamics, I'm going to keep dyne for short, and structure mechanics. I'm going to put mech for short, and I put complex analysis. I'm just going to put CA for short. And so I did the process of elimination to start off with this. And then I told myself, dynamics, it's a cool class, but I really don't want to talk about that right now. It's a pretty tough course. And then there's structural mechanics. And if I had a lot more time in my hands, I could probably do some pretty interesting stuff with this course, with this subject. But since I'm a pretty busy college student, I don't think that's going to work out, so I said this. So down came to complex analysis. I looked at this class and I said, well, looks like this class wins by default. And then, so today we're going to talk about how to derive Euler's identity. And what Euler's identity is, so the way I came up with this topic was I walked to my professor's office, I asked him, hey, I need help with the topic. I have a presentation coming up and I want to talk about something interesting. And he said, okay, all right, Jesus, now tell me, what is e to the I theta? Now, for those of you that don't know what E is just a number. It's 2.7148, I believe. That's roughly about that. And then I is just an imaginary number. And for those of you that don't know, yes, there is imaginary numbers in math, which is makes it a little bit more complicated. And theta, it's just a representation of an angle. So say it can be 30 degrees, 40 degrees, or 100 degrees. It doesn't matter. It can be anything. And now he asked me, what does this equal? And I said, well, of course, it's cosine theta plus I sine theta. And then he said, oh yeah, cool, now derive it, and prove it. And I was like, okay, so I'll prove it. And then, so I looked at this, and then I said, I have no idea where to start. Where do I begin, Professor? Come on, like, I don't know what to do. And he said, well, you learn a subject, something called a Taylor series. Now, for those of you that do not know what a Taylor series is, a Taylor series is an expression of a function into an infinite sum of terms. So I'm going to write out the Taylor series with this guy. So this is what it is. So e to the, well, to generalize this, I'm going to use omega instead of I theta. E to the omega is equal to, and I believe I just forgot it, so 1 plus omega squared over 2 factorial. And I'll go over what factorial means, like a little crash course. It looks complicated, but it really isn't. And then this can go on infinite times, so I can have theta to the power of infinity. This can go on forever and ever. And when omega, say if I say this is equal to 2, and then if I plug in 2 values forever and ever, I'll get closer and closer to this value. So that's how a Taylor series works. So it's like pretty much like an expansion. I'm expanding a function. And so I started off with this, and I said, okay, I can probably work with this. So now I'm going to say this. Let's let omega, hold on, omega equal to I theta, right? Because that's what we have here. So I'm just going to plug in wherever there's a omega, I'm just going to plug in I theta. That's all I'm going to do. So here we go. So e to the I theta equal to 1 plus I theta plus, here we go, I theta squared over 2 factorial plus I theta cubed over factorial. And I'm going to take it to the, where it comes to the power of 5. That's how far I'm going to go. Because you guys will later on see down the line why I need all the way down to the 5th. 4 factorial plus I theta to the 5th over 5 factorial, and so on and so on. And now, like I stated, I was going to explain what factorial is. Factorial, all it is just, so say if I have 2, so it's just 1 times 2. And if I have 5, it's just 1 times 2 times 3 times 4 times 5. And same with 4, so 1 times 2 times 3 times 4. That's all that factorial does. And now, I saw this and I said, okay, now I can mess with this a little bit more. I'm just going to do some algebra, right? And now, algebra, just do some stuff. So, I squared, for those of you that do not know what how an imaginary number works, I squared is equal to -1. So, I'm just going to plug in, do some algebra real quick. So, I'm going to make a list before I do it. So, I'm going to do I is equal to I squared is equal to -1, I cubed, and I can factor out an I squared, and that would be I squared times I, which is, look at that, I squared times -1, it's just negative I. And then I to the 4th is just, if I expand I to the 4th, I get 2 I squareds, and that's just -1 times -1. If you guys, so if I do 2 negatives to multiply 2 negatives together, what do I get? What do you guys know? Positive, right? So I to the 4th is just 1. Alright, and we're just going to keep on going until we get to the 5th. So I to the 5th is equal to I squared times I. And then, like I said, this is I to the 4th right here. It's just 1. 1 times I, it's just going to be I. Okay? So now I'm going to do the algebra real quick, and all the arithmetic. So I theta is equal to 1 plus I theta plus, and look right here, we got an I squared. So that would be -1. So we can take out this plus sign and put negative. So the I squared, the I, there's no more, it just goes away now. And we're just left with theta squared over 2 factorial. 2 factorial. And plus I cubed, that will be negative I theta cubed over 3 factorial. Let's see. Plus, yeah. Plus 4 theta to the 4th or 4 factorial. And to the 5th, that will be I theta to the 5th, 5 factorial, and this can go on and on. Alright, so we got down to here. I looked at it and I said, alright, I'm stuck again. I don't know what to do. And then I asked my professor, now what? What do I do now? And he said, introduce 2, well, he says, if you were a genius, you got this, you're done. But clearly I'm not. So I did, and he said, if I were a genius, you look at it, you're done. And then he said this, include 2 more Taylor series expansions. What can you include? What other functions? I can do ln of x, something. I can do something else. I said, okay, let me mess with this more. And that's what I did. So I'm going to come over here. So I was not sure of this. I was just like messing around. I was like, and he's like, yeah, and he was like, uh-huh. And I was like, okay. So he pretty much gave it away right there and then. And I forgot the extension for this. And that would be 1 minus v4 factorial. And then he said that, and he was like, uh-huh, keep it going. I was like, okay, I'm going to keep going. Or I already knew what the final answer was, because it's something that I've already learned before, but he just wanted me to derive it. So I was like, okay, I'm going to keep going. Pretty much he gave it away for me. And then we got to here, and I said, okay, so v minus v plus v to the 5th over 5 factorial. And these guys can go on and on, like infinite. They can go, it's going to take forever for me to write out the whole term, so it would be here all night. So we got there, and I just told myself, all right, I'm going to let v equal to theta this time. Let v equal to theta, and I'm going to see something. Equal to 1 minus squared over 2 factorial. 4 over 4 factorial. On and on. Sine theta equal to theta minus theta cubed over 3 over 5 factorial, and this is on and on. And now, if you guys, now right here, I just paused for a bit and I was like, okay, I'm stuck again, now what? And then he gave me this one advice. He told me, look at this equation and look at the differences and separate how they're different. I looked at it and notice how some of them have I terms, right? And then others, they don't. So I'm just going to separate the ones that do have an I and the ones that don't. I'm going to take it over here right now. So I'm going to separate them. I'm just going to put e to the I theta. And I'm going to put them in brackets to like separate them. So we got what? 1 plus, no, not 1 plus. It's going to be minus theta squared over 2 factorial plus theta to the 4th over 4 factorial. And then bracket plus minus, I'm just copying it down, just separating them, plus I to theta to the 5th over 5 factorial. And these guys can go on and on forever and ever. And now, if you guys look at this, they're pretty much the same. I'm just going to take this guy and that guy. So I'm just going to write in wherever there's cosine theta. And since this is going on forever and ever, I also know that there's no longer going to be an I. It's all theta terms. And for this one, when I go forever and ever, there's always going to be an I. And then I told myself, all right, let me factor out an I for this one. So I'm just going to factor out the I. Algebra. And now look at this one and this one. They're exactly the same. So now that I know that they're exactly the same, I can plug in something. I can plug them in. Is equal to cosine theta plus I. And then this is just sine theta, which is that series expansion. Sine theta. Now, I'm left with this equation. And my professor said, yeah, Jesus, you got the answer. Now you should change to a math major. And I was like, okay, that's never going to happen. I just want to be an aerospace engineer. Okay, and then once I got to here, and then I walked out of the office, I was thinking to myself, I never truly understood what this equation means. I always learn this, I always see them in my math courses or my engineering courses, but I never truly knew what it meant. Like, what does it do? Like, it's just an equation. I don't, so what? And then I took it home, I thought about it more and more, and then I was doing some dynamics homework and I had to do something called polar coordinates to solve a problem. And then I thought to myself, polar coordinates, hold on. So I'm going to draw a graph real quick. It's just, and then let's assume that I have like R, this is the length, it's just the length. I'm just going to label R just to generalize it. R can be 1, 2, 5, 3, infinity, 3. And then this angle can be theta, and this theta can be anything, 30 degrees, 40 degrees, 90 degrees. And then I know, for those of you that know like the basic trigonometry, the opposite over hypotenuse and adjacent over hypotenuse, SOHCAHTOA, right? SOHCAHTOA! There you go. So you know that sine, for this y value, y is equal to r sine theta, right? And for this one, it's just x is equal to r cosine theta. And that gives me the point right here. And that's just x and y in the Cartesian plane. Now in the complex number plane, this is x plus iy. Now in a complex plane, the way that the y value behaves is the complex numbers, and then the way the x values behave is the x values. And I saw these guys, and I was like, hey, wait a second. So that means e to the I, or it can be r to the ei theta. That means e to the I theta is just a point on a plane. That's all it is, e to the I theta. So that's what this means. It's like, it's a point. That's it. It's just a point. And then when I got here, I said, oh no. When I got here, it's pretty much like the correlation between the real numbers and complex numbers. It's like the bridge, like this equation connects the two. And now, when Euler, when he derived this, he set theta equal to pi. And so that's what I'm going to do here. Whatever there's a theta, I'm just going to make it equal to pi. And we're going to come out with such a beautiful equation. And this is what's I sine pi. right? And now sine pi, I sine pi, or for those of you that may have taken trig, do you guys know what it is? 0. So it's just, this guy's going to go away. And cosine pi, who knows what cosine pi is? What is it? Negative 1, yeah. So e to the I pi is equal to negative 1. And this makes perfect sense when I was looking at this graph. It's just, when I was looking at this graph, it made perfect sense because like e to the I pi would be around here and it would just be negative 1. And so when Euler, he did not stop here. He predicted like one simple algebra trick and he just did this. So that is equal to I plus 1, it's equal to 0. And this is currently, Euler derived this equation, and this is probably the most beautiful equation you can ever see in mathematics. And Euler, arguably the greatest mathematician that has ever lived. And this is currently on his gravestone, and I believe he's buried in St. Petersburg, I believe. And that's currently on his gravestone, and it's currently hanging in David Barber's office. Yeah, when I came to this, it's pretty much just the point, and then where this equation, this formula is used heavily in electrical engineering for those that they have to know how complex numbers work and how they can relate, because it just makes their calculations easier. Because AC waves, they can be seen as complex waves. And so the way it began is, so that's pretty much the story on how I came to talk to you. This is pretty much, that's the story on how I learned how to do this. So I began with saying, I don't even know what the e to the I theta, and then I went down to the Taylor series, and then I just went on from there, and I simplified it to this beautiful equation. That's it, guys.